We'll now look at some of the basics of factoring. So the idea of factoring is before we learn that we have this product, that we can multiply it out to get this right-hand side polynomial. So the idea of factoring is to go backwards, to start with a polynomial and write it as a product. And these two polynomials, these two terms that are being multiplied, are called the factors. So it's basically the opposite of multiplication. We can have a prime polynomial. Primes just means it cannot be factored, so not everything can be written as the product. So for example, something like x plus 1 is in as simple terms as it can be. Another one, 3x minus 2. Also x squared plus 9. So these are all prime polynomials. And the first thing we're going to look at when factoring is common factors. So these are things that are common in every single term. So we can see with this one, we have 3x minus 6. And we can see that 3 divides into both of these. So I can rewrite this as 3x minus 2. And this works because if we try to go backwards, 3 times x is 3x, and 3 times negative 2 is negative 6. So it does work. My next one, 2x squared minus 6x plus 4. We need something that divides evenly into all three of these. And we can see that that's 2. If I remove a 2 from 2x squared, I'm left with x squared. If I remove the 2 from negative 6x, I'm left with negative 3x. If I remove the 2 from 4, I'm left with 2. The next one, 6x minus 15. We can see that 3 divides evenly into both of these. 3 times 2 is 6, and 3 times 5 is 15. A couple more. The next one, x cubed plus 7x squared. So far, everything we've done had a number in common, and we can see that there's no number in common here. The coefficient of the first term is a 1 and the second is a 7. However, we can see that they both have x's. And in fact, they both have an x squared. So we can factor this out. X squared times x is x cubed, and x squared times 7 is 7x squared. And sometimes we can factor out both a number and a variable like this. For instance, in my next example, we can see that 3 divides into both 6 and 9. And in addition, they both have an x term. So I'm left with 3x times 2x plus 3.